All right, hello class. Um, Today you are going to be learning about the distributive property. So if you want to write down the goal, if you need to pause it here, the goal for today is to use the distributive property to simplify expressions. So it is right here on the screen. We're going to use the distributive property to simplify expressions. And now just um, make sure that you are taking notes on this stuff. This is just like a normal class day. I want you to take notes and write down things that seem like they're important. And a lot of this will be important, especially the examples. Those are what are usually the most helpful for students. So we are going to go on and take a look at the warm-up. All right, here's what I want you to do. It says in your favorite video game, maybe this is your favorite, maybe it's not. Tetris is always a classic. Um, you rotate shapes as they fall to make them fit together in a rectangle. When you complete a row, you get a point. So when you complete a row, it goes away and you get a point for each square in that and for each square in that row. The screen at the right shows your latest game in pause mode. So you have all the shapes available on this screen over to the right. Using only the shapes shown, what is the maximum possible score for this game? Explain your reasoning. So basically, take some time, and if you want to if you want to look at, you can make some shapes like this, like I did, that are to fit to the form, or if you want to go on Moodle and upload this presentation, you can also play around with the ones that I made, even though they aren't perfect. So I'm just going to play around with a little bit, see what the best score is that I can get. So we'll start with that one there, that one there. Put that there. Put that one there. All right, here's what I got. This looks like it's the best that I can get so far. I'm not sure if it's the best that you can get. If you can try and get something better, I would go ahead and try it. But if you look here, I think I got 1, 2, 3 full rows. I know they're not perfect, but I think that's the basic gist of things, if they're all perfect shapes there. I think I got 3 rows. So 3 rows for every square, and each one of them is a square, so it looks like there's 1, 2, 3, 4, 5, 6, 7 squares per row. And 7 times, I've got 3 rows, gives me 21 points. So I got 21 points. That's the best that I could get, and there's only 2 extra up here. So if you can, try to move it around and figure out if there is an even better way of doing it. All I did with the pieces up here is I rotated a few of them to fit them in there. All right, rotating is totally legal. And the point here is, what we did was we moved things around. We switched them, we rotated them, we moved things around to get them to fit how we wanted them to fit. So it simplifies the most. It got rid of the most things and it simplified it. What we do in math, and especially using the properties that we've been talking about, and the new one that we'll talk about today, is rewriting things, moving things around so that we can simplify them. And that's exactly what today's objective is having to do with. Using the distributive property, we're going to use it to simplify things. We're going to simplify expressions from it. All right. So if you look at the challenge problem for today, I'll make it big and we can read it together. I want you to, this is what you should be able to figure out by the end of class. You can figure out the recommended heart rate for exercise in beats per minute by the expression 0.8 times the quantity 200 minus y, where y is your age in years. So again, this is the recommended heart rate for exercise based on your age. This is your little expression here. What you need to figure out by the end of today is how to rewrite this using the distributive property, and then also what your recommended heart rate would be based on your age. All right, so think about that as we go on in today's lesson. Okay, I went too far there. All right, here is what I want to look at. Find the area, the total area, not just the area of each one, the total area of this whole big rectangle using two different ways. All right, go ahead. You can pause it if you want. You can try to figure it out on a piece of paper. Try to find the total area using two different ways. All right, one way you might want to do it is by realizing that, well, area of a rectangle equals base times height. So if we want the whole rectangle, we know that the area would be the height, which is 8, times the base, which is this whole thing. So to figure out what this whole thing is, you just add them together, so you get x plus 10. So we'll multiply it by x plus 10. I'm sorry. X plus 10. Alright, and I'm going to move this on down. That's one way of finding it. So just be multiplying that. We can't really multiply it out yet because we don't really know what it would be, since you cannot add an x and a 10 in the parentheses. Those are not like terms, so you can't add them together. What we can do, though, is figure out another way of finding it. You might have looked at this and said, well, I can figure out that the area of this smaller rectangle plus the area of this a little bit bigger one would get the area of the total one. And since this side over here is 8, this side over here would also be 8. So we'll just do 8 times x, 8 times x, or 8x, which would get you the area of the first one, 8x. And we can add that to the area of this one, which is 8 times 10, which you know is 80. And you get your whole area. So what we did was two different ways to get the same area. So we can say that they're equal, because the area is going to be the area no matter what. You're not going to have a different area. And this right here is the distributive property. If you notice, this 8 basically was distributed to the x and to the 10, because now it has an 8 in front of the x, an 8 in front of the 10, and that's the distributive property. So I'm going to put it into mathematical words. We can look back at this one. This is a great example to demonstrate the distributive property, but I want to show you it, how we would define it in algebra. All right, so I'm not going to put too much at you at once. First of all, for addition, you need to see it in the algebraic format because it's really important to know. When you have something in the form a times b plus c, just imagine there could be numbers in there, maybe there's not, maybe some of them have numbers. What's happening here is you're distributing the a, that's why it's called the distributive property. And since this whole thing is multiplication, a times that, you're going to distribute that multiplication of a, to the b and then to the c. And you'll get a times b, and you keep that addition sign, plus a times c, because you distribution c as well. To put it in different terms, we know that 4 times 20 plus 6, and you can simplify that 20 plus 6 for this one and the inside and then multiply it. But using these numbers might be a whole lot easier to figure out the answer in your head. So you can distribute the 4 times the 20, which is right here, and add that to the 4 times the 6, which is right here. And 4 times 20, that's a pretty easy one. If you figure it out, it is 80. And then you add 24. You get 104. It's a whole lot easier than thinking of what would 4 times 26 be. Takes a little bit more work that way. So the distributive property is really nice in that respect. All right. And again, make sure you're writing this down. This is a really important concept to know. Second one is just a little bit different. The only thing that we're changing here is now we're using subtraction. And if you notice, this is subtraction here. The only thing that changes, you're still distributing the A to the B and the A to the C. You're just putting that subtraction sign in the middle there instead of addition. So an example over here would be you have 7 times 12 minus 4. Now you can figure out what 7 times, I don't know, 8 is. Sorry, 7 times 8, which is 56. Or you could keep it like this, like the distributive property, and distribute that 7 to the 12, which would be 7 times 12, and 7 to the 4, which is 7 times 4, and then keep that subtraction sign in there. And you can figure that out. Now 7 times 12, I believe, is 84. And 7 times 4 is 28, and you can subtract that out and you get the same answer as you would over here. You'd end up with 56. So you notice it works the same way with subtraction. And the distributive property does work. Alright, so I would like to try this one as well. This time we're going to throw in some letters and numbers in the same problem. So take a second to see, based on the distributive property, if you need to scroll up here, based on the distributive property, what we did here, we distributed the A to both and we kept the sign in the middle. Figure out what the A, B, and C would be in this one and use that distributive property. So feel free to pause this and try this one on your paper. All right, so if we did this one, again, this is going to be your A. So this is what's the thing that's outside. It's going to be distributed to everything on the inside. And so the 16 is going to distribute to the X. So it's going to be 16X. It's also distributed to the 2. If you want to picture that box from the slide before, you're distributing that 8 to the X and that 8 to the 10. And keep that subtraction sign in the middle. And then distribute the 16 to the 2. And what you can do here, you can't simplify this anymore. 16x is as small as it can go. Minus 16 times 2, which is 32. And you're done. Because 16x is a different kind of term than 32. So you can't subtract them. They are not like terms because there's an x in one and there's not an x in the other. So they are different. And that's as simplified as you can go. So rewriting this using the distributive property gets you to this. 2 different ways of writing the same expression. Now, let's try a couple together here. These are a couple tricky ones. They're not super tricky, but it's still using the same idea of the distributive property. The only thing with the first one is you might have to use another property to make it easier on yourself. And this property is one that you've learned before. You actually learned yesterday. It's called the commutative property. And if you remember commutative, you think of commutative, CO, change the order. So let's just change the order of these two. I'll rewrite it and put the negative 2 out in front to help me picture it better. Now it looks like this form up here that is really helpful, and we can do that. All right. So in blue here, let's distribute this to this and this to this and keep that subtraction sign in the middle. So negative 2 times 5b minus negative 2 times 4. Now, when we multiply this out, negative 2 times 5 is going to be negative 10. Keep the negative 10b. Okay, and then this here has 2 subtraction signs in a row, so you can take the opposite of a negative 8, or you can just make them both positives right away, and you'll get plus 8. And that is your answer for that one. So just doing a little switching around helps things a whole lot, makes it easier on us. All right. Now the second one does not have a number out in front, but it does have a negative sign. So if you think back yesterday to the negative property of multiplication, if you multiply anything by negative, it's going to make it a negative. So you can think of this of two ways. You can say, I have a negative in front, so I have to make everything inside of it opposite. Or what I want you to picture is, that's when you have a negative, that's really the same thing as saying -1 times what's on the inside. So a negative just means it's a -1. All right, and then you can do the distributive property. Distribute that out, and you will get -1 times 2y minus a -1 times 3x. Again, the first part, you're going to just multiply this out. -1 times 2 is going to be -2y. That's simplified. You can change these both to positives and get plus 1 times 3 is 3x. And you cannot add x's and y's. It's like adding apples and bananas. They're two different things. Keep them separate. And that's as simplified as you can go for that one. Now the last one is just totally division. But you can also use the distributive property here, which is kind of neat. We know that if you divide by a number, it's actually saying you're multiplying it by a fraction of 1 over that number. So for instance, 20 divided by 2 is actually the same thing as saying 1/2 times 20. Believe it or not, 20 divided by 2 is 10. I hope you know that. 1/2 of 20 is also 10. So that's the same thing there. So what we're going to do is we're going to rewrite this so that this 5 on the bottom is actually taken out in front, and it's a fraction. So we're going to rewrite that as 1 over 5 times this whole expression here of 7x plus 2. Now it's in the form that we like for the distributive property. And I'll keep going back to that. This form right here, either one of these forms, which I will actually go ahead and make this nice and fun. And if it works, circle this all in smiley faces because these are so helpful. If we know that, that's the form that we like it in, we can just use that distributive property. So, back to this problem. Sorry, back to this problem. It's in the form that we like, so let's just multiply it out. Let's just distribute that 1/5. So it's going to be distributed there and there, and you're going to keep that addition sign. So 1/5 times, so 1/5 times 7x plus 1/5 times 2, and maybe you skipped a step and already did this in your head, but 1/5 times 7 gets you to 7 over 5. Not much you can do there, x. Plus 1/5 times 2 would be 2 over 5. Just multiply straight across on the top. And there's your simplified form. If you write it out with the distributive property. All right, so what I would like you to do, I have two problems based on what we just talked about. Please pause the video and try these two on your own paper and then come back and see how you did. All right, welcome back. We're going to just do the distributive property with these two problems right here. And then we'll be good to go. We can try our challenge problem, and I will be happy with this. So, this problem is already in the form that we like. The one that's circled all in smiley faces here. So what you have to do is just distribute. This is all distributive property, distributing it, and keeping that subtraction sign. So we'll make this one, let's try yellow. So 12 times 3 minus, keeping that subtraction sign, 12 times 0.5x. All right, go into green because green and yellow makes Packers colors, and we all love the Packers, right? 12 times 3, if you look at that, that is 36. Minus, what is 12 times 0.5? We did that one yesterday, I believe it is 6. So 6, and then you still have the x. And 36 and 6x cannot be combined. You can't subtract anything there because one has an x and one does not. So that is our simplified version. Now the other one is this negative 4x minus 12. We did one like this before. Very similar. The only thing that we need to remember is that when you have a negative out in front of parentheses, that actually means negative 1 times that. So if you want to rewrite it, negative 1 times 4x minus 12. And then you can go ahead and distribute that negative 1 to both. Or if you can picture this, just distributing the negative to both. That would be negative 1 times 4x minus a negative 1 times 12. Remember, there's only two negatives. There's a subtraction sign and then the negative. So we have two negatives here. What I would do then is multiply this one out. Negative 1 times a 4 would be negative 4, so the x. These both will make a plus, so we can add 1 times 12, which is 12. And we have our nice distributive form, negative 4x plus 12. So I hope you've got those. And if you didn't, make sure you fix them based on this problem. Now last, let's check this one out. This is our challenge problem. If you know that your distributive property, this should be a piece of cake. So, again, you can figure out, if you really want to, you can figure out the recommended heart rate for exercise in beats per minute by this expression here. And I'll highlight this one. This expression here, which is 0.8 times 200 minus y, which is in the form that we know for distributive property. If it's in that form, you should think, oh, I can distribute that 0.8 to both of the parts in the parentheses. So, first of all, number one, rewrite the expression using the distributive property. So we'll rewrite it. If you have, so number one here, 0.8 times 200 minus y. Let's distribute it. First things first. Distribute to the first one and then to the second one. So if you need to use your calculator, go ahead and grab it. 0.8 times 200. I'm actually going to use my own calculator to check this one to make sure I'm right on. I believe it's 160. So 0.8 times 200. It does. It's equal to 160. So that is 160 minus 0.8 times y, which is as simplified as you can go. So all you have to say is 160 minus 0.8 y is your new expression. We still have to figure out what is your recommended heart rate. So we'll figure out for you. I'm guessing that you are probably either 13 or 14, so you'll probably be turning 14 this year. We'll go with a 13-year-old. Let's say your years in age y equals 13. This goes way back to last week's material of evaluating an expression. You can plug that in. So 160 minus 0.8 times 13. And if you do that, 0.8 times 13, sorry, wrong one. 0.8 times 13 is 10.4. So you have 160 minus 10.4 equals 149 149.6. That's what your heart rate should be if you're a 13-year-old when you're exercising. So if you ever check your heart rate, maybe you will in Phi Ed this year, you can go ahead and tell your teacher that, hey, when I'm exercising, my heart rate should be right around 149.6. And if it's not, then we got to figure something out. All right? So you can go tell Mr. Rundog that. All right, here's what I need to do next. Again, follow your sheet, your Google Doc that I have for you. But for practice time, make sure that you are self-assessing yourself. This is something you should be doing every day. I like that you're writing down, a lot of you are writing down the goal, but you still have to assess yourself on it. So make sure you're doing that. Then there's a distributive property worksheet. It's on Moodle. If you can't get internet at home and you don't think you'll finish it in class, go ahead and ask the substitute teacher that she will have some copies of it. The distributive property worksheet, that's what it's called on Moodle. And then if you finish that early and your self-assessment, make sure that you are going to Moodle and going under weekly work. There's weekly work from last week that you probably didn't finish because not many did. And then there's new weekly work for this week. And I'm going to tell you right now, this will be graded. I will be grading some weekly work this week. Okay, so I do expect you to do as much of that as you can. There should never be any downtime today. All right, so if you have any questions, try to ask the substitute teacher. Otherwise, you can ask me when I get back. And have a great day.